Ooh la la!
Hi everyone and welcome to this lesson where we are going over part 3 of this angle series that we have been covering. In this lesson we will be looking at angles within more shapes, and this lesson is going to focus on quadrilaterals, and in particular we will be having a look at squares, rectangles, kites, rhombuses and parallelograms. We will be looking at what each of these shapes are and the different angles that we can find within them, and also go over a few example problems. Okay, so the first type of shape we'll be looking at today are quadrilaterals. Now you might have already guessed by the name, but quadrilaterals are literally shapes which have 4 sides, which is indicated by the term quad here. And one other thing about quadrilaterals is that all of the angles within inside the shape add up to give 360 degrees, which if you remember before, we said that is equivalent to one full rotation about of point. So the first and most basic type of quadrilateral we'll be looking at are squares. Now we've all saw a square before, but we're going to define what actually makes up the shape. So a square is a quadrilateral which has 4 equal sides and also 4 right angles within each of the corners. So if we have a square, we can say that this corner, this one, and this one are all right angles, which means that each corner has an angle of 90 degrees. And if we have 4 corners, if we add 90 plus 90 plus 90 plus 90, or just simply 90 times 4, then we get 360 degrees. And we know that all angles within a quadrilateral add up to 360 degrees. And it just so happens in this case with a square, each of the angles are the same, therefore they are equal to 90. One unique thing about a square is if we draw a diagonal line from corner to corner, we can see that what this does is divide the square into 2 equally sized right angled triangles that has 2 equal sides here. And because we knew at first the angle within a square is 90, this line goes directly through the middle of that angle, and therefore the angles within the corner of the new triangles are 45 on all sides of the shape. One thing that's also worth indicating that we touched on a couple lessons ago is that with a square we have 2 sets of parallel lines. The first one indicated by these arrows and the second pair indicated by these arrows, because they're directly opposite each other and they have the same angles. And we also know that if we have right angles within the shape, then there's also going to be perpendicular lines. And as we mentioned before, that just simply means that if we have the right angle, the lines that form the right angle, so this one here and this one here, are perpendicular, and the same can be said with this line here and this line here, because they join to make a right angle. Okay, so the next type of quadrilateral we're looking at are rectangles. Now rectangles are quite similar to squares in the fact that they also have 4 right angles, as we can see here. But what makes them different is that rectangles don't have all 4 equal sides, but in fact only the opposite sides are equal in a rectangle. So for example, this side here is equal to this side here, and this side is equal to this side. And that's all these lines mean, by the way. Once I've drawn the lines, if they have the same lines on the same side, then that just indicates that the sides are equal. So this side is equal to that one, and that is equal to that one. So in a rectangle, we only have opposite sides that are equal. One thing we mentioned about squares in the previous slide was that the diagonal line that joins either corner created 2 symmetrical triangles. So to give an example, here we have a square and it's been split in 2 by this diagonal line connecting either of these opposite corners, and what that does with a square is create 2 identical or symmetrical triangles. Symmetrical just means that they're the same about this line here. So imagine this line acts as a mirror, and therefore either side of this line is the same by having equal triangles. But for a rectangle, this is not the case, and this is because that all 4 sides in a rectangle aren't equal like in a square. we only have the opposite sides are equal. And what that means is, when we draw a diagonal line connecting both of the corners, because the sides are different lengths, the angles on either side of the diagonal lines are different. So, for example, we can see that this angle here is smaller than this angle here, and the same again for either side. This angle here is smaller than that angle there, and because that's the case, then the angles are not symmetrical about this diagonal line. And another way that we can picture this, as we said before, we can imagine that this line almost acts as a mirror, and if that's the case, if we flip one of the triangles over onto the other, they don't perfectly overlap like they would in a square. If it flipped over, then this angle would end up somewhere in here, and therefore we know that it's not symmetrical. Okay, so now we're going to have a look at a problem where we have a rectangle, and within that we have two diagonal lines connecting the corners together. And what we've been given is this angle of 70 degrees right up here. And using this information and the geometry we have with this shape set up, we've been asked to calculate angle A. Now there's various ways that we can go about a problem like this, and we will look at them right now. Okay, so the first thing that we have to consider is that for these four triangles that are created by drawing the diagonal lines through the rectangle, we can see that the opposite triangles to each other are equal. So for example, the blue triangles are both equal and the yellow ones are both equal as well. And what that means is the angles are the exact same and the lengths are the exact same. And the other thing that we have to consider is that all four of these triangles are isosceles triangles. Now we mentioned before that an isosceles triangle is one which has two equal angles and two equal sides, and that is what we see here. So having considered that, we are going to look at the first way we can solve for angle A. So we're going to begin up at this corner here and find out the angle for this, because that angle lies within the same triangle as angle A. And if we can first solve other angles within the same triangle, then hopefully later on we'll be able to solve angle A. So for this one in here, we know that in the corner the angles have to add up to 90 degrees. Therefore, this angle must be equal to 20 degrees, because if we know that one is 70, then that angle must be 20, because 70 plus 20 is equal to 90 degrees. And because we know that each of these triangles are isosceles triangles, therefore two of the angles are equal. And because if we know this one is 20, then this one also must be 20 here, because we know that if this side and this side are equal, then these angles must be equal as well. And therefore, finally, to calculate angle A, we can remember the rule that all angles within a triangle must add up to give 180 degrees. So we know that angle A plus 20 degrees plus 20 degrees is equal to 180 degrees, because that's the rule for every triangle, that all three angles must add up to give 180 degrees. Therefore, using a bit of algebra, we can say that angle A is equal to 180 degrees. Take away both of the 20 degrees, so minus 20 degrees, minus 20 degrees. And if we do that, we know that 180 take away 20, take away another 20 is 180, take away 40. Therefore, angle A is equal to 140 degrees. So another way that we could solve this problem is by using Z angles or alternate angles, which we covered before. And we know that to do this, we need a set of parallel lines and one diagonal line running through the both of them. So what we can do is, here we've drawn this red line, which runs directly through the middle of angle A, and we can say that that line is parallel to this line here, and this diagonal line here cuts through the both of them, and because we have that, we can therefore identify the Z or alternate angles. So if we draw this out in blue, just to give an example, we can see that the Z runs down past the 70 degrees onto the diagonal line and runs back up this red parallel line here, and therefore this angle of 70 degrees can be flipped over and mirrored within here, and therefore this angle is also equal 70 degrees due to following the Z shape between the parallel lines. And because we know this angle is equal to 70 degrees and that the red line that we've drawn runs directly through the middle of the triangle, then this angle here on the opposite side must also be equal to 70 degrees. And therefore, because we know that angle A lies where both of the 70 degrees angles are, we can say that angle A is equal to 70 degrees plus 70 degrees. Therefore, angle A is equal to 140 degrees. So that's just another way of proving angle A, what the value is. So the first way, we used the rule of right angles and saying that the angles within a triangle add up to 180 degrees. And in this example here, the second one, we used Z angles or alternate angles to help us get the value of A as well. Two methods which both work in this case, and you can pick whatever one feels more comfortable to you, but in the end both of them get the same result. Okay, so the next quadrilateral we'll be looking at are kites. So what defines a kite is that it's made up of two isosceles triangles joined back to back. Now we can draw that in. Let's say we draw a line, a straight line, connecting both of the points together. We can say that this is an isosceles triangle, and so is this one down here. Therefore, we can say that in a kite, that side is equal to that side, and this side is equal to that side. And the other thing about kites is that the diagonal lines, so this line here running from top to bottom and left to right, they cross each other to form right angles. So we can see that all of these angles within here are right angles. Okay, so let's have a look at a little problem related to kites and angles. So let's say we want to figure out what the value of angle A is, and we've been given this value here of 40 degrees. Well, we can say straight away from this rule that the diagonal lines form right angles, that both this angle here and this angle here are equal to 90 degrees. And we also know that because we've split this top isosceles triangle in half by this diagonal line here, we know that this triangle on the left is equal to this triangle on the right. Therefore, if we were to draw the mirror and represent it on the other side, we know that all the angles be the same and all the lengths are the same also. So that would mean that this angle is also equal to 40 degrees because it's the mirror angle to this 40 degrees we have on this side here. Therefore, we can take this triangle. We already know two of the angles. We know that this is a right angle and we know that this one is 40 degrees. And the rule of triangles is that they all must add up to equal 180 degrees. Therefore, we can say that angle A plus 90 degrees plus 40 degrees is equal to 180 degrees. Therefore, if we take the 90 and the 40 over to the other side, we can say that angle A is equal to 180, take away the 90 and the 40. Therefore, angle A must be equal to 50 degrees. Okay, so now we're going to have a look at a shape called a rhombus. And what defines a rhombus is a shape that has 4 equal sides and the opposite sides are parallel. So for this shape, we can say that all of these sides are equal and the opposite sides are parallel. So we can say that this line is parallel to that one, and also this line is parallel to this one. Now I've drawn a square here to point out the differences between a rhombus and a square. If we look at both of them, we can clearly see that they're different. But what I've said here is that a rhombus is a shape which has 4 equal sides and the opposite sides are parallel. But the same can also be said for a square. So the main difference between a rhombus and a square is that a rhombus does not have right angles. We can see that a square, each one of the corners are right angles, but for a rhombus this is not the case. We can see that both the top and bottom angles are equal, but they're clearly bigger than 90 degrees, and the angles on the left and right are both equal as well, but they're smaller than 90 degrees. And the difference between a kite and a rhombus is that we said before a kite was two isosceles triangles that were different and sat back to back, but for a rhombus this is also the case where we have two isosceles triangles, one here and one here, sitting back to back, but both of these triangles are the same, but for a kite they are different sizes. Okay, so the final type of quadrilateral we'll be looking at is called a parallelogram. Now that's quite a long name, but essentially all that means is a shape which has opposite sides that are equal and parallel, hence by the name parallelogram. So what we can say is for a parallelogram, this side is equal length to that side, and this side is equal length to that side. And we can also say that they are parallel as well. Now the thing is, a parallelogram can not only look like this shape here, it actually covers quite a wide range of different quadrilaterals. So for example, a rhombus, which we touched on in the last slide, is actually a type of a parallelogram because a rhombus has opposite sides which are equal and parallel. A square would even be described as a parallelogram because that has the same as well. Even a rectangle can be classed as a parallelogram. All it is simply a quadrilateral which has opposite sides that are both equal and parallel. So let's recap what we've covered in this lesson. We defined a quadrilateral as shapes which have 4 sides and angles that all add up to give 360 degrees. We said a square was a quadrilateral which has 4 equal sides and has 4 right angles. We said that a rectangle has equal opposite sides and 4 right angles. We said that a kite is a type of quadrilateral which consists of 2 isosceles triangles which lie back to back. We said that a rhombus is a shape which has 4 equal sides and that the opposite sides of the rhombus are parallel. And finally, we said that a parallelogram is a quadrilateral which opposite sides are equal and parallel. I hope this video has been helpful to you. Thanks again for watching, and I'll see you in the next video.